Hello and good morning. So we are from Group 5. Today we present our presentation which was 5G mobile network performance analysis. So our team member consists of Alifa Eliana, Nofarisha, Nosarafina Nadia, Hyun Yun San, Kim Zayang and Muhammad Nafiz Ihsan. So this is the outline, what contained in our presentation, which was content introduction, methodology, result discussion and conclusion. So for the introduction, let me explain what is the 5G. So 5G is designed to significantly speed up and improve our network. So with 5G, our internet connection may transport speed at higher speed, which was transport at multi-gigabit per speed, which the bit rate could reach at as high as 20 gigabit per second. So how we measured 5G for our project, which was for the first, for 5G, we need to consider and abide the certain rules set by governing authorities like 3GPP. So one of this specification is upload and download. Next is 5G also has minimum latency requirement, which was describe the interval of the time between the cell tower data transmission and the destination device data reception. So for our project, the 5G speed coverage was measured at Sri Serdam to obtain the result and making an analysis. So this is the objective for our project. So which was the first is to measure the speed of 5G coverage of the specific telco at different area, then say Serdam. Next is to analyze the throughput, which was the download and upload rate, network latency, and packet loss performance of the mobile network. Next is to compare the data analyzed with different parameter and condition.
Now is the part for the project methodology. In our methodology for this project consists of 3 tools to be used for network measurements. The tools are speed test, OpenSignal, and 5G test. On all of these tools, we'll be taking list of parameters for performance comparisons and analysis. So we will be analyzing the download speed, the upload speed, ping, and packet loss. Other than that, we also analyzing certain conditions when taking the network measurements, such as during the rainy day, during the sunny day, indoor and outdoor. Based on our analysis, the performance of the network are vary with different conditions. Next, moving on to the locations and the telco that we'll be using. The locations that we are decided for network test and analysis will be inside the Seri Kembangan Selangor. The list of the locations for Tower Block, Faculty of Engineering, University Health Center, PKU, JW Equipment, Sinar Berhad, Paris Chocolate, Alice Nature Cafe, Sedang Hospital, Library Faculty of Engineering. And the telco that we'll be using is 5G Celcom. 5G Celcom. As verification, this is the coverage of 5G Celcom test. As you can see, the 5G Celcom covers a lot of space in Seri Kembangan. Hence, during our measuring analysis, there are no drawbacks of getting a stable connection of 5G Celcom during our test analysis and performance.
When it comes to our results, we performed 5 comparisons, namely between different devices, between different apps, between indoor and outdoor, between rainy day and sunny day, and between high and low traffic periods. For each management, we took 3 readings, and we also calculated the average of the readings to improve experimental reliability and to reduce contingency. The app comparison was made. The apps we tested are Speed Test, OpenSignal, and 5G Test. We got the readings from 3 different locations, namely the Tower Block, PKU, and Kedai Buku. From the bar chart, 3 apps shows the similar results. We decided to use Speed Test for the following comparisons, because it provides more performance parameters. When we measure the data for device comparison, all the readings are taken at the same time and at the same location using both devices side by side. The readings were measured from 3 different locations, namely Burley's Chocolate Company, Alice Signature Cafe, and JW Equipment Company. Lots of the parameters are considered. From the bar charts, we can discover that In general, both devices shows the similar network performance, but iPhone 13 Pro Max shows slightly better performance. We speculate this because the body of the iPhone 13 Pro is badly damaged, especially the part where the antenna is placed.
Hi, Elena here. So let us dive into the indoor and outdoor comparison, where the indoor measurement is presented in a darker blue color over here, and the lighter blue color represents the outdoor measurement. For both the download and upload measurement have shown that outdoor gave better data transmission and reception than in the venue. The idle time of the network also suggested that the outdoor venue has lower time compared to indoor venue. These are the other parameters that are taken into consideration. What I wish to highlight is, as you can see, the packet loss varies according to the place, which will be analyzed on the very next slide. There are few insights we can gather from the graph. Firstly, we believe that the outdoor network performance is better due to the better cellular coverage. Secondly, the transmission of data is influenced by the construction materials of our building and the human movement. So in summary, it can be inferred that wider spaces and materials that are transparent to electromagnetic wave lead to a better data transmission. Okay, next. Okay, let us now get into the comparison between weather, which are between rainy and sunny day. Thankfully, due to the current monsoon season, we managed to evaluate the data transmission in this weather. It is worth to note that these measurements are taken on the same day to avoid any data inconsistency. Rainy day is represented in blue, while the sunny day is actually represented in yellow. These results of measurement for both data transfer and reception in both directions, download and upload, show that sunny weather have superior performance compared to raining day. So furthermore, the network's idle time also support this, as it is lower in sunny day, okay, compared to raining day. Okay. So if we examining packet loss more, we can perceive based on the graph that most of the data were attenuated on the raining day compared to the sunny day. This graph actually offers several observations that we can draw from. Firstly, we believe that network performance during sunny day is better than rainy day due to only one reason: tropospheric loss. This type of loss occurs as the transmission is weakened by the absorption and scattering of signals by the raindrops. In summary, although it is unavoidable, during rainy day it is actually expected for our data transmission to be attenuated compared to sunny day, which results in a bad network performance. Next, I'll pass to Sun.
The next comparison is on network performance during peak hour or non-peak hour. Based on the bar chart shown here, the download speed for low traffic and upload speed for low traffic is higher. The ideal jitter, download ping, download jitter, upload ping, upload jitter, and packet loss during low traffic is lower. Overall, network performance during non-peak hour is better. This is because the number of users accessing a network in the same location or area affect the service performance, and available bandwidth will be shared among different users. When there's more users, the more divided the available bandwidth will be. Moving on to the discussion on results obtained earlier, according to OpenSignal, Malaysia achieved high rankings in all three 5G speed categories, with download speed ranging from 382.2 megabit per second to 880.3 megabit per second, and with upload speed of 50.3 megabit per second. Comparing results from previous slides, download speed is within the mentioned range, whereas for upload speed, most of the results obtained show more than 50.3 megabit per second. And according to another article published by OpenSignal, the speed of 5G upload speed is 16.8 times faster than 4G, whereas the download speed for 5G is 6 times faster than 4G.
If we compare the speed from 3G to 5G, from 3G, it can take up until 26 hours to download a movie. While 4G, it can take up to 6 minutes only, and 5G, you can get only around 3.6 seconds. But for the response times between 5G and 4G, for 4G, it will be around less than 50 milliseconds, while 5G, you can get only 1 millisecond, which is in a blink of eye.
Okay, next is the 3GPP or ITU overview for 5G. So as we know, the ITU is in charge of overseeing, evaluating and monitoring the entire 5G technology. So what can ITU provide us with by ensuring the newly built 5G network can connect people globally in equitable manner and benefit humanity. In addition, 5G network also can be secure, interoperable, and they can operate without causing and receiving harmful interference or from adjacent service. So for the 3GPP is the network protocol that we smart abide that will, for 5G, it will enhance the mobile broadband eMBB. So in other words, is having a higher data rate. For example, for the downlink, up to 50 Mbps are offered for outdoor and 1 Gbps for indoor. In addition, we must abide the critical communication CC or ultra reliable and low latency communication. So which was, in other words, is having an extremely high reliability as expected. So the user can experience the data rate up to 100 Mbps and end-to-end latency of 50 ms, which, for example, the application is the edge through the edge computing capability.
For the conclusion, the overall readings have achieved the minimum requirement for 5G release by the ITU and 3GPP. It is possible to receive the download rates over 1 gigabit per second if we're in the right area, which is 20 to 30 times faster than standard 4G LTE. However, the proper phone and the appropriate CT are crucial since 5G isn't even close to being widely used yet, and the many technologies that make it up are still a bit of a muddle. Because 5G isn't just one technology, having a variety of technologies is essential. It's a compilation of many advancements, including antenna design, cell towers, and a larger range of radio spectrum. Your experience of 5G may also vary widely depends on the telco device and the location. And that's all from us. Thank you.